David Smith here with one more Flip Classroom math video. 3 tips before you start. First, you could speed up or slow down the playback if that helps you get through the video at your own pace. Second, you could pause the video at any time to catch up with your notes. Third, you could turn on the captions and watch my words go by on the bottom of your screen. Let's manipulate our data points and see what happens. And this is going to give you the opportunity for some practice with your calculator. So first off, here's our test scores we used in the last example, and I just summarized all the stats that we can say about them. So there's our X-bar, our mean, our median, our mode, our standard deviation, sigma, our sigma squared, the variance, and then our min, max, and the range, and the interquartile range. Okay, so now what I want you to do this in your calculator, is add 4 to each of the data points. So this one's going to become 22, this becomes 26, this becomes 30, and so on. So do that in your calculator, and then recalculate all of these values and write them down in the spot there. So go ahead and do that, and then come back and we'll see what you got. Let's see how you did. So when I went to my calculator and I added 4 to every data point in here, what I've got is my mean increased to 65.9, my median, my mode also increased. That makes sense because I just increased every value by 4. So these values just increased by 4, as did that one. Now, my standard deviation stayed the same. Now, think for a minute. Why would that be? Why wouldn't that increase? Well, it's because my data just shifted 4 higher. Every number is 4 higher. So the spread is still the same. It's still the same characteristics of the spread. So standard deviation and variance did not change. My min changed by 4. My max changed by 4. But how about my range? That stayed the same. It's still, from the min to the max, is still the same number, as is the interquartile range, because the Q1 and Q3 just increased by 4. So when you subtract Q1 from Q3, you're still going to get interquartile range of 32. Now, I'm not sure about your calculator, but my calculator doesn't give the interquartile range. It just gives the quartiles, which I can then use to calculate my range. One last exercise. Instead of adding 4 to each data point and comparing the new statistics with the original with this data, now I want you to multiply each data point in here by 3 and then calculate your new stats. So you're going to multiply this 18 by 3, that becomes 54. That's your first data point. You'll multiply this 22 by 3, that's going to become 66. That's your data point, and so on. Get those in your calculator and then run your stats and write them down, and we'll come back and we'll talk about it. All right, let's see how you did. So now we're comparing our original stats to our stats where we multiplied all the data points by 3. We increased them by a factor of 3. So as expected, my mean increased by 3. Basically, we just multiplied this mean by 3 to get the new mean. That's not what we did. We calculated it based on our new data, but that's what ended up happening. Same thing with my median and my mode. They just got multiplied by 3, so we're at 186 for those. Now, check out my standard deviation. Unlike when we added a number to each database and the standard deviation stayed unchanged, the standard deviation got multiplied by 3 as well. So, interesting difference there. And it makes sense because we multiply the bigger numbers in our data set by 3, so they go further away from the smaller numbers. So when you multiply every number in a data set by some constant, you're going to increase the spread of your data, and that's going to increase the standard deviation and the variance. The min and the max, all we did is add, we multiplied again by 3 to get our new values. So 18 times 3 gave us our new min, our new max. So our range also got multiplied by 3, as did our interquartile range. And I made that same mistake here. This is IQR. So there you have it. All right, let's summarize the results of that last somewhat complicated and long set of exercises there. So basically, if we have values for a data set like these are the ones that we've been exploring, and then we take some constant n and we add it to every value in that data set, what's going to happen is the mean is going to increase by n, so do the median and the mode. Standard deviation and variance will stay the same. The spread of the data does not change. The min and the max will increase by that same number, but the range and the interquartile range will stay the same. And the summary of that pretty clearly is that when you add a point or a value to every data point, some of the values change, like the measures of central tendency change, okay, because we've moved our data over by n, so all the central measurements are going to go over by n, so that's the plus n's on all of these. But the spread of the data stays the same. We just move the data set over by n, so it's not narrower or wider, okay? And then it also follows that if we subtracted by n for every data point, the same thing would happen here. We'd get minus n for all the plus n's, and these would stay the same. Now, this is different when you multiply every data point by the same n. Now we are going to not only move the data down a bit, and we're also going to increase the spread of the data. So that's why in every case, except for variance, we multiply by n squared. In every case, we're going to multiply the original values by whatever that n is that we multiplied every data point by. Now, you might be asking, great, you did a bunch of math there and we found some relationships. How am I going to use this? So what you're going to see in the exercises and on the tests and quizzes is you're going to see some questions where you're going to need to use this information to answer them. Like one scenario might be that a teacher gives a test in a class and they want to curve it. So they want to increase the average by a certain amount. So they're going to tell you what the n might be. And it might be they want to increase the average by multiplying it by a number or adding a number to it. So that's one application of this concept. So be ready for that. Now that you've watched the video, take a moment to jot down any remaining questions so you can ask them in our next class. If you want, you can come back and watch the whole video again if that helps deepen your understanding. If you enjoyed the video, please click like or subscribe.